Hey, hi guys. Good evening. Good evening. Welcome to Cat Ninjas. Welcome. So let's continue our discussion on numbers. So of course, we'll be doing a different kind of a topic, that is how to find the last two digits of a number. We'll classify the data into five different models. We'll put the number into five different models, and then we will try and see how do we find the last two digits of an exponential number. That's one model which is kind of asked in time, asked in CAT time and again, right? So therefore, let's try and explore this particular thought. And probably already in tomorrow's lecture, we will also do about how to find the unit digit of an exponential number. So these are the two kind of questions which repeatedly come in exams like be it CAT, it can be XAT, it can be IIFT. Any of these kind of exams that you write, these are two very typical questions which come to find the unit digit of an exponential number and to find the last two digits, that is units as well as the tens digit of the exponential number. Okay, so I spoke. Let's quickly understand that you are all able to hear me out. So I'm clearly audible. Let's try and see. It's kind of audible there. Good evening, Keval. Good evening. All good? All right. Yeah. Yeah. Great. Hmm. Fair enough. Then we are good to start. Let's go carry on. Let's go ahead. So here we start. So let me quickly introduce myself, and I'm Belvi Srinivas, and I've worked since 2007 in various test prep organizations. That's about 14 years now in various capacities, both on the side of management as well as training the students, training the trainers, right? And over a period of time, yes, I did develop expertise to train students effectively in the areas of QA, DI, and yeah, that's briefly about me from the training background. Yes, alright, if you would like to interface and then you want to connect with me, so maybe you can use this particular Telegram channel. And through this particular channel, you can ask me some brief, short questions or short counselings. I'll be able to help you out, right? That's a little bit about how we can get connected. And yes, so these are the two kinds of subscriptions the Unacademy offers. The one is a plus, the other one is a star. Actually, it is not star, it is actually termed as iconic subscription, mentioned in the form of a star. Yeah, so what does the plus do? With a lot of educators, there are a lot of educators launch various kinds of batches on the plus platform. So it could be of various difficulty levels, but each time they launch a particular course, there is always a background in understanding to it, and they do it in a much structured manner. So you will get the access to the structured courses across the verticals. It can be verbal, RC, it could be DI, LR, or quantitative aptitude. So you get that access structured courses on each of these areas. And you can also take up multiple courses during that point in time. It is not that you should be doing only one course at a time. You can also do multiple courses. You can do a course on verbal parallelly. You may be doing a particular course on DI. You might take up a particular course on quant parallelly. Of course, we need to ensure that the times do not clash. That's how you kind of have to plan this. Yes, all right. You will also get you'll also get weekly tests, structured tests, structured sectional tests, so a bit of study material, all of this. But Iconic, in addition to whatever the plus offers, in addition to that, you also get to speak to your mentors in whatever the concerns that you have. You would be able to speak to mentors one to one, right? One on one. You will be able to you can kind of book the slots and you can speak to them about what? Speak to them about it could be the content, in the sense it can be your concepts, it can be your doubts. Also, it can be with respect to the test analysis, how to improve the scores, or it could be with respect to the test planning or study planning, right? B school planning, all of which it can be your SOPs, all that you can kind of connect with the mentors and you can discuss with them. Yeah, ensure that, because you will guys will be filling a lot of application forms going forward, especially the B school application forms. If there is anything that comes out about the question saying that your goals or about you, why you want to do an MBA, tell something about yourself, whatever be the kind of questions which come in, or your interest, or at times it can be your sometimes your academic achievements, non-academic achievements, all of which. Just ensure that always these questions are shown to one or two people who understand it from the professor's perspective. Only then submit those questions, because they're very, very critical for your selection. Not just that the questions come in the interview, not necessarily. That form is very, very important at the selection stage. A lot of understanding and the opinions are drawn based out of that particular form. So ensure that that form is always shown to somebody before you kind of fill. Not just the data form saying that 10th marks is this, 12th is this. That doesn't matter. Whenever the B school application form comes with certain questions, ensure that that's always shown to someone before you submit that form. Okay, so that brings us, that also can, that kind of understanding also be taken from your one-to-ones. Yeah. So all this comes at certain nominal price, the subscription charges for plus courses where you will not get one-to-one interaction with the faculty members. These are the prices. So on which you kind of get 10% discount if you use any of the educator code, including my code, right? You can use the educator code and then you can avail 10% discount on these listed prices, and suitable 6 months, suitable for CAT 21, CAT 22, CAT 23, and so on. So if you are looking at CAT 21, the preferred subscription could be the iconic subscription, because in the next 6 months you may need quite a bit of one-to-one interactions. Therefore, it is always preferred from that perspective. I'm not saying that, okay, if those who are appearing for CAT 22, CAT 23, it is not preferred, and it's need of the hour. For if you look at CAT 21, if you are looking for subscription, that makes much better sense. And if you have enrolled for any of the CAT, any of the plus, or be it the iconic subscription, so you will get 2 full-length tests on CAT every week, and this two is minimum which everybody should write, and one of them must be written on Sunday during the daylight hours. That's between 9 and 6. It is must. Everybody should be writing this on Sunday. It should be put on the autopilot mode. Come Sunday, you should be taking a mock, full-length mock you must be taking. The results later, but habits important. Get into the right habit to start with. All right, so there we go. So that brings me to the closure of the announcements, and we are good to start with the concept. Give me a feeler as to who all have joined in out here. Let me quickly know who all are in the meeting. Yeah, give me a sense of who all are in the meeting here, so you can say, yeah. So put this, let me know just. Those who are there in the meeting can exchange your greetings quickly. All right. Nazia is in the meeting. Rishabh is in the meeting. Mohit is in the meeting. Sarthak and Keval. All right, great guys. Good. Okay, here we go. So I will classify this to find the last two digits into five types. Basically, I will classify this into 5 types. So any type, it shouldn't take more than a minute. A minute is actually a longer time. Some of the models will just take about few seconds. Basically, honestly, you'll understand it. Yeah, some of them may stretch up to less than a minute, kind of based on the complexity of the problem. Otherwise, generally, anybody aware of all the classification of this data into 5 types shouldn't really bother to find the last two digits of the number. It should not really bother them. So how do I classify this into the 5 types? First, let me give the classification, then we will learn each one of them with a couple of examples. How do we do this? So the exponential number is a raised to power b. I'm talking about the last two digits of a raised to power b. I'm talking about this. Focus on a. Based on the classification is based on the base, not based on the power. Power is nothing to do with us. Classification is based on the base. What is the base here? A. So therefore, I will classify the data. I will classify into 5 types based on. I will classify based on A. What is A? A is the base of the number. So, okay, now coming to A. Therefore, let me now focus on A. Now, again, on A, I will classify this based on the units digit. All right, based on, so I am talking about last two digits, correct. But the classification is based on units digit of A. Classification is based on unit digits of A. Okay, what can be the unit digits? So, okay, number one, type 1. So classification based on unit digit of A. Type 1 is the unit digit of A is 1. I'm talking about the unit digit of A when it becomes 1. What is this type 1? The unit digit is 1. Hey, is there a tens digit to the base A? Is there a 100 digit? They all may exist. But I'm saying that the classification based on unit digit being 1. Second type, the unit digit being 9. Unit digit being 9. Third type, The unit digit being either 3 or 7. Unit digit being either 3 or 7. Type 4, unit digit being 5. So what did I do? I covered all odd numbers. Base, whenever the base is odd, so I covered all odd numbers. 1 is covered, 9 is covered, 3 covered, 7 covered, 5 covered. And therefore you have one last case, which is nothing but an even number. Type 5, any even number with a unit digit. Basically I'm saying that the unit digit of A is even. Unit digit of A is even. Even means what? It could be 2, 4, 6, 8, whatever is the even digit there. That's what we are kind of talking about, right? So 0 will not make sense, because you may say that unit digit, the number can end with 0. No brainer, if the number ends in 0, easy to find the last two digit. Therefore, that doesn't matter. So even, basically even. These are the 5 types. Let's learn, attack each one of them. Okay, you understood the 5 types? You got it, how the classification is made? Any doubts in the classification itself? Let me know. So how did I classify into 5 types is clear? Confirm, quickly confirm from the other side. Classification is clear. 5 types are clear, because that is how you also learn. That is how you also store the information in your mind. Right? The storing is also done like that, so that retrieval is easy. If you store properly, retrieval is easy. Always we need to learn in a much structured manner, for a simple reason that you will be able to reflect and retrieve faster. Right? If you don't learn in a structured manner, retrieval becomes a challenge. It becomes very, very difficult to retrieve the information. Right? Okay. All right, at least 3 of you are saying that you understood. Keval understood, Rishav got it, Mohit got it. I'm assuming that others also kind of got it. Whoever is in the meeting, I'm assuming that they also kind of got it. Maybe they have a little bit of difficulty in typing is what I guess. Okay, so let's go to the type 1. Let's go to the type 1. Let's try and see how do we work with this particular type. Okay, let's try go to the type 1. So say for example, all right, the last two digits of 61 raised to power 63. All right, Sarthak and Nazia, thanks for confirming, guys. Okay, 61 raised to power 63. We need to find the last two digits of the number. Okay, I will just do for a couple of them as to how we kind of do it, but we don't use all of it. So we have to understand the mnemonic at the end of it. But yeah, it's good to know, maybe to get a start, it is good to know how actually at the background this stuff works out. It is good to know, fair to know that. So therefore, first one, let me explain. The number ending in 1, type 1. This is the type 1. What do you mean by type 1? The unit digit has to be 1. That's it. All right, the base. In the base, the unit digit of the base has to be 1. How do we technically do it? Which means given this question to the 11th standard student in the board and saying that there are marks for the steps. How does that fellow would approach? This fellow would approach it something like this. 60 plus 1 raised to power 63. He makes it as a binomial. So from that binomial expansion, then he goes on to expand this. He will say that NC is 0. The first term, he will write the first term 630. He's writing the terms of this. 630, that is the NC is 0, and then 60 raised to, all at 60 raised to power 0 and 1 raised to power 63. This could be the first term of the binomial. Okay, then he goes on to write the second term of the binomial. 63 C1, 60 raised to power 1 and 1 raised to power 62. Okay, I'm just expanding it so that you are clear what I'm writing the expansion of. This 1 raised to power 62 doesn't make sense, we know. But I'm just expanding x plus y raised to power n. Basically, I'm expanding this. I'm putting it to perspective. I'm hoping that those who are preparing for CAT 21 would at least know the binomial expansion. Yeah, I will not get into the details of it, how, what, when, because I'm not teaching that portion. I'm just telling you that, okay, those who are interested. So this is how it technically works. Okay, third term, if you're writing the third term, you would write the 63 C2 60 square and 1 raised to power 62. 61. Then you might write the fourth term as well. You might write this as 63C3, 60 raised to power 3 and 1 raised to power 60. Likewise, fair enough, right? This is how you kind of write this particular part. Okay, yeah. What is that you are asking, Vivek? I asked it out in the comment in Telegram regarding first question of second lecture of nonlinear. Yeah, guys, somebody, those who have time, just let Vivek has put in something in the Telegram, try and address it. So if nobody is able to address it, then I will address it. Okay, yeah, help yourself. There are a couple of people in the Telegram group, right? So you guys can help each other. All right, if you have something on the non-linear, please help Vivek on that, right? Yeah. And if nobody is able to help, then let me know. Just ping me. In that case, like, put that to me. I will help you out, right? The help each other, that's always a good virtue. Yeah. Okay, so here we go. Here we go. Sometimes I will also help some reconfirmations, etc. I will do. So if it is good, it is good, right? So I think the doubts you can help each other there. Okay. Yeah. Fair enough. Let's come back to this. Let's come back to this. Yeah, 63C0, 6001, we know that if you are writing, I'm focusing only on the tens place and the units place. Okay, let me write hundreds place also. This becomes 100. We all know what is 63C0, that is 0, that is 1. So this 60 raised to power 0, 1, this is 1, 1 into 1 into 1. The last three digits kind of looks like 001. All right, yeah, let's come to the second one. How does this look like? So let me expand this portion a little bit for you on the left hand side. So 63C1 is 63. What is 60 raised to power 1 becomes 60. What is 1 raised to power 60 to 1? I just expanded these three pieces. I said that hey, what is the value of 63C1? I wrote this and I wrote this. Fair enough. So unit digit is 0. No doubt unit digit is 0 because why? Because there is a 0. Unit digit has to be 0 here. Now what about the tens digit? Now listen to me very, very carefully. Tens digit will be a product of this. 6 into 3, 18. The tens digit is 8. Am I interested in the 100 digit? No, I am writing this tens digit as 8. Observe this very carefully. I wrote the tens digit as 8. 63 into 60 into 0. What did I do? I can also write this as 63 into 6 into 10. Okay, therefore, the unit digit of this particular product is 0 because of this 0. Unit digit is 0. How I get my tens place? Understand that. Tens place is this 6 into 3. 6 into 3, 8. That is what you kind of write there. Okay, what about the hundreds place? I'm not really interested in the hundreds place, right? Hundreds place, I'm not interested because I'm interested in the last two digits. Why bother about hundreds place? Let me write 80 and let me not worry about the hundreds place. Let's remove this from the matrix. Okay. Now coming to this, what about the third one? 63C3, I'll let third here, 63C2. If I expand this, I can get the value of 63C2, that is 63 into 62 divided by 2. Good. And then I have 60 square. So at 60 square, when I write 60 square, I understand that the last two digits are zeros. Why? What is 60 square? 60 square is nothing but 60 into 60. Therefore, what will be the last two digits of this particular product? Invariably, the last two digits are 0. Hereafter, if I see 60 cube, naturally the last two digits are 0. And hence I say that, hey, so except the first two terms of this binomial, nothing else is going to contribute anything. Only the first two digits are first two terms. This is my first term and this is my second term. Only the first two terms contribute. Rest of the terms simply contribute zeros thereafter. So first two terms expansion, therefore I will just add it up 80 plus 00. I will add up these two terms and I say that the last two digits are 81. That's it. All right. This is going to be my answer. If somebody were asked in the 11th standard, show me the steps. This is what somebody could have done there. Okay. Now, having understood this, what do we do? So for us, it becomes a 5-second problem. What do we do? Listen to the understanding here. 61 raised to power 63. Only two number unit digit. By default, write the unit digit as 1. I'm writing the answer. Unit digit is 1, right? Unit digit, because any number ending in 1 raised to any power, the unit digit has to be 1. You can't say that, no, 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 sir, unit digit has become 3. I wonder how unit digit has become 3. Unit digit won't become 3, right? So I'm writing the units place on the tens place. Any number ending in 1 raised to any power, common sense, the unit digit is 1. No proof required for it. Okay. Now the idea is how to write the tens digit therefore. That is the only idea. Tens digit is always, you got to focus on the unit digit of the power. Listen to this very carefully. Unit digit of the power and the tens digit of the base. Only these two things matter. I'm putting the arrows there. Only these two arrows matter. Unit digit of the power, tens digit of the base matter. To find the tens digit of this complete expansion, unit digit of the power and the tens digit of the base matter. Okay, how does it matter? Multiply. Take the product of them. What is 6 into 3? 18. Now pull out the last place of this power. What is the last place of this product? 8. Pull this out. I will do it once again. Listen to this carefully. First of all, whenever such numbers are given, what matters to find the tens digit? Because unit digit is no brainer. Unit digit is 1. We said that that's no brainer. Okay. Yeah. What matters to me is the tens place. So how do I find the tens place? To find the tens place, unit digit of the power matters. Hey, what about the tens place? Doesn't matter. The tens place of the base matters. What about this one? That doesn't matter. Doesn't matter for what? Doesn't matter to find the tens place of my answer. Okay. So therefore only this 6 and 3 matters. Now, okay, if matters, in what sense it matters? I have to take the product of this 6 into 3. I take the product of this, I will write this as 18. Now out of this 18, which one I should copy? You should copy the last place of this 18. What is the last place? Which is nothing but 8, which becomes my answer. Okay, now listen carefully. Let me do the other one. So you'll be able to make sense of this. Let's see the question on the other side here. So let's see the question here. This is the question. Let's try this. Okay. What matters? I'm writing the units digit of the answer, tens digit of the answer. Unit digit is 1. It is no brainer. Why? Because the unit digit is 1. 1 raised to any power. Unit digit has to remain 1. You cannot come back and prove me that, sir, for this question when I solve I get unit digit as 5. It doesn't matter. Any high school student will tell the unit digit is 1 for this. The idea is to find the tens digit. What matters for the tens digit? Unit digit of the power matters, the tens digit of the base matters. You may say that what about this 3? Doesn't matter. What about this 1, 2, 3? Doesn't matter. All that matters is we should understand what matters. This 4 matters, this 8 matters. 8 into 4, I will take the product of 8 into 4, which becomes 32. Out of this 32, I need to copy this to last place. Right? Copy this. 21 is the last 2 digits of the answer. Therefore, how long it will take? 5 seconds. If the number is ending model 1, type 1 question. If the number ends in 1, already if the base that ends in 1, you understand that in 5 seconds you'll be able to give me the answer. Is this clear, everybody? Is this clear? Clear? Type 1 is clear. Give a quick confirmation. Type 1 is clear. It doesn't take much effort. Type 1 clear, everybody. Type 1 is clear. Give a quick confirmation. Technically, it's a 5-second problem, right? Hmm. Just a second. I went offline here. I'm trying to put it back online. Yeah. Great. All right. Okay. Now quickly give me the answer because I said it's a 5-second problem. So give me the answer quickly here. Give me the answer quickly here. 1, 2. Okay. Let me write it as 6, 5, 4, 3, 2, 1 raised to power 1, 2, 3, 4, 5, 6. Yeah. Answer. Find the last 2 digits of this. Quickly type it. It shouldn't take much time. Fast. Find the last 2 digits fast. Fast, guys. Give me the last 2 digits other than Cable and Rishabh. All clear here. Good, good, good. Only 3 are getting the answer, is it? Vivek, will you stop that thread? Stop that thread. You discuss it later. Discuss it. You can discuss that on the Telegram also, right? So use it here. Use this time judiciously to learn something, right? Don't mix up the issues. You can take it offline also. After the lecture also, you can discuss that, right? Let's be wise with our time. Let's be wise. When you are here, be here, right? So that already somewhere Keval has given that. Figure it out later. If it has missed out somewhere again, he will do it. What big deal about it? It's a 1-minute task. He will figure that out, right? Yeah. So when we are here, let us be here. So otherwise, K will get disturbed, others get disturbed. Okay. I hope you appreciate my point. We can take it offline. Let's be wise with our time and talents. That's my point. Let's be wise. So when we are here, let's be here. That will make a lot of sense. Okay. Good. All right. Let's go to the second model. Let's go to the second model. Yeah. So second model, what is the second type? Second type is the number ending in 9, right? Second type is the number which ends in 9. Okay, what do I do? Now listen, hey, when I'm finding the last 2 digits, what does it technically mean? You got to understand this point. Now I'm coming to the true point. I'm coming to the true point. Say, for example, if I have a number 126, I want to know the last 2 digits of this particular number. Assume last 2 digits of this number. Simple. It's a remainder when the number is divided by 100. If I want to understand the last 2 digits of any number, it's technically the remainder when the number is divided by 100. 100 one time, 100. Therefore, the last 2 digits are 26. Okay. If I want to understand the unit digit of 126, let's say if I want to understand unit digit, you got to divide this by 10 and the other remainder becomes the unit digit. Okay. Therefore, you say that 12 times of 10. Of course, you will do it in multiple steps, no doubt. 12 times of 10 is 120. Therefore, the remainder is 2. 6. Okay, similarly, if I ask you that, hey, I have a number 3482. I want to understand the last three digits of this number. Simple, you got to divide this by 1000. 1000 three times is 3000. Therefore, 482 are the last two. That's an actual algorithm. What is the actual algorithm? When you want to find the last two digits of any number, you got to technically divide by 100. In the sense, when I'm asking here 29 raised to power 184, please tell me last two digits. It's pretty simple. You are supposed to be dividing this by 100 and you should be recording the remainder, which becomes the answer. If I ask the same thing, man, 29 raised to power 184, please tell me what are the last three digits of this number. That's a 100 digits in the hundreds place, digit in the tens place, digit in the ones place, right? So if I ask you that, all you got to do is take this and divide this by 1000 and tell me what is the remainder. That remainder becomes the answer. That's the algorithm. Technically, this is what the issue is. If you want to understand what exactly is that we are trying to do, we are trying to do this. Okay, now listen, having understood this. So now let me come back to this. What I do on the type 2 is, or what I do, the moment I see a number ending in 9, I know that my unsaid divisor, tacit, the unsaid divisor here is 100. That's a tacit. It's not visible, but that is what it is. All right. When I say that, tell me the remainder, you know that your divisor is 100. For all these problems, it's 100. You use it or not is your wish. But is it there? Of course, it is there. So your unsaid divisor is 100. Let's use it. Therefore, I will say that, man, I will take 129. I will divide by 100. It's a deliberate strategy. It's a strategic issue. What I'm trying to do here, I will simply divide 29 divided by 100. I want to understand what is the remainder. Remainder is minus 71. I'm okay with it. I'm okay with it. So I will deliberately divide. I will write the negative remainder. That's a deliberate strategic decision. 29 divided by 100, it will become minus 71. Fair enough. But author said that, hey, who asked you to find the last two digits of 29 by 100? I am saying that find out for 29 raised to power 184. We already did the divide. We already did the remainders. Therefore, we are comfortable. Therefore, you are saying 29 raised to power 184 is what you want. Therefore, minus 71 raised to power 184 is what I want. Both are saying 29 raised to power 184. I wrote the negative remainder minus 71. You raise it to the power 184. Therefore, here also I will raise it to the power 184. And hence, this becomes what? Therefore, you say that, hey, this problem has ultimately become 71 raised to power 184. Why? Because the power is even. So, even power of negative sign. So, that would become this. I will now find the last two digits of this particular answer. I know unit digit is 1. Because the number is ending in 1, unit digit is 1. All the thing is I have to just figure out the tens digit of this number. 7 into 4. 7 into 4, 28. I will copy this 8 here, which becomes my answer. What did I technically do? The moment I saw 9, I converted this to 1. That's what I tried to do. The moment I saw 9, I converted this to 1, and then I attacked this particular question. What did I do? I brought it down to my comfortable territory. What is the comfortable territory? The number ending in 1 is pretty comfortable. 5 seconds problem for us. I brought it down to the comfortable territory and I attacked it. How did I do that? By using the negative remainder concept. By using the negative remainder. Why negative remainder? I know that the unsaid divisor is 100 here. Okay, point clear. Type 2 point clear. Concept clear on type 2. What did I do is the type 2 problem I convert to type 1 problem. Concept clear. Everyone give a quick confirmation that you kind of understood. It's a deliberate strategy to write a negative remainder. Unsaid divisor in all our problems is 100. Whether we use it or not doesn't matter. 100 is the unsaid divisor when we are trying to find the last two digits. 1000 will be the unsaid divisor when we are trying to find the last three digits. Simple. Okay. Yeah. We use or not is a different issue. Okay. We use when we want. We don't use when we don't want. Guys, other than Prashant, Keval, Mohit and Nazia, others are also fine. Are you following me? Why don't you just move your fingers and give some confirmation? It gives a sense of confidence to the speaker also. Please understand. Right? Why I ask is that also helps me to modulate the pace, all of that. Okay? Good. Yeah. Nice. Nice. Oh, good. Rahul, you are there. All right. Good. Okay, find the last two digits of 359 raised to power 123. Now again, 100 digit doesn't matter. See, the question is 359 raised to power 359 raised to power 123. 3 doesn't matter. 3 doesn't matter for a simple reason. Why 3 doesn't matter? 100 digit cannot contribute back to the tens digit. I am interested only in the units place and tens place. Hundreds place cannot contribute backward. Hey, will the units place can contribute to the tens place? Yes, in the form of a carry, right? In the form of a carry forward, that contribution is there, but there cannot be a backward contribution here, right? Yeah, backward contribution here. Okay, yes. So when you do this, all right, when you do this, okay, this looks an important query. Screen does not looking clearly. So you may have to, oh, so yeah, all right, what you may have to do is you may have to go to the settings. All right, now there will be some three dots on your screen. Somewhere there will be three dots. Click on those three dots. Then it will ask for the settings because my camera has 1080 pixel. What is that, guys? 1080, that's right. That's right, 1080 pixel, right? After 720 is this 1080? That's what the pixel generally the cameras use. I think so, yeah, 1080 pixel. So therefore it will give a lot of clarity. Clarity wise, there is no issue. At my end, there won't be an issue. Okay, at your end, you may have to do the settings. Osoya Dharita, right? Yeah, you may have to do that. So as far as I understand how I do my settings is, there will be some three dots on the screen somewhere on the top, or you just click, you will get some three dots there. Go to those three dots, click on that, it will ask for it and change that configuration. That's how you change settings at your end, because at my end, I don't think there is any issue there because I'm using the best possible camera. Increase quality, that's right. Rahul is saying that increase quality. Go to quality, increase it. Yeah, Rishabh is saying that already if there is a problem with bandwidth, 480 also works well. You set it, whatever it is. Okay, I hope all of this helps. Now I don't want to give too much of technical guidance on this. I know you are smart enough to figure that out. Figure that out. All right. Yeah. Okay. Let's go in here. Uh, this is to you also. Yeah, I think like no, you're smart enough to figure that out. Okay. If you need little more help, somebody can help out here definitely. In case you still face a problem after 2 or 3 minutes, you try and then you let us know. We will help you out. Okay. 59 raised to power 123. So this is the question there. 3 does not help because it was 359. So in your case, very good, smart, very good, Osaya. Yeah, 59 raised to power 123. First deliberate strategy, take a 59, divide this by 100 and write this, I'll write a negative remainder. It's a deliberate strategy. What do I write there for? Minus 41. So 59, I look at it, I write this as minus 41. But author said that, hey man, I am not asking for 59. I'm asking for 59 raised to power 123. I raise this to power 123. I raise this also to the power 123. Okay. Then you say that, hey, it's an odd power and there is a negative sign. No problem. So what I do, I keep that odd minus number outside. I deal with 41 raised to power 123. Let that minus be there outside. There is no problem with us. Let that minus be there. 41 raised to power 123. I will deal with this bracket. No problem. 1 is the units place and 4 into 3. This is what you look at. 4 into 3 is 12 and 2 matters to us. Therefore, you say that 21. These are the last two digits of the number which is within the bracket. But minus sign is outside. Fine. So unset divisor is always there. Hey, minus 21 are the last two digits. We know the unset divisor of the, which technically the remainder. Technically, you are trying to say that if 59 raised to power 123 when divided by 100, the negative remainder is minus 21. That's all you are trying to tell me. Okay, how to convert it to the positive? We know tacit divisor is always 100 in our mind. Add 100 back and call this as 79, which becomes your answer. This is what happens in case the number becomes negative. That's it. All right. Now, so as usual here, even power here, when you are trying to do this here, 184 and the power is even, the minus sign did not affect. But what if the power is odd? All right, if the power is odd, it might, negative sign might continue to remain. What do you do? Come to the last step, convert it to positive and give the final answer. Okay, so model 2 is clear. I'm closing with 2 examples. No need to give more than 2 examples because these are very simple ones. After that, you will already, after that, you solve it. I've just illustrate 5 models and I'm done. Model 2 is clear. Type 2 is clear. The number ending in 9, the deliberate strategy of dividing by 100 and converting it to a number ending in 1. All it is that clear. Strategy is clear. Right? That's type 2 story. Right? That's a type 2. Type 1 is number ending in 1. Type 2 is number ending in 9. Guys, quickly confirm. Yeah, quickly confirm. Move your fingers faster. Yeah, good. All right. Makes sense. Type 3. Let's go to type 3. What is a type 3? Type 3 is number ending in either 3 or 7. Type 3 is the number ending in either 3 or the number ending in 7. That is what we mean by type 3. There is one intermediate step which comes in the picture here. I'm sure all it knows, so whichever the trainer that you followed, etc. I'm sure by now, because we are just about 70 days to CAT, by at this point in time, you would be kind of very, very clear that somebody would have told long time back when you started your preparation, hey guys, you got to know squares till 25. So it is not that method to calculate squares till 25, but you got to remember squares till 25. 1 square, 2 square, like this up to 25 square, because they know that there are multiple applications which emerge out of this. That's precisely the reason they said that you better remember till them, because nobody is going to ask you the squares in the CAT, etc. The idea is there are applications which will be built around that. From that perspective, you should know. They also mentioned that, hey, it's also wise to know the cubes till about, cubes till 15. Let now 1 cube, right? So cubes till 15, 1 cube, 2 cube, like this up to about 15 cube. And along with this, they would have mentioned small other things as well. Okay, coming back to this. Today I am going to use this, therefore I just reminded you about it. If somebody were kind of, why I didn't learn them yet, it's better you better learn them, so that it gives you some speed and momentum in certain applications. So I'm using this for now. For now, I'm using this 1 square, 2 square, up to 25 square. What do I know? If I say my number for numbers which lie between, for all numbers which lie between 1 and 25, for all natural numbers lying between 1 and 25, the last two digits of, listen to this very, very carefully, the last two digits of. So because there may be hundreds place, there may be thousands place, I'm not interested in hundreds and thousands place. When I say last two digits, I'm talking about the tens place and the ones place, also called as units place, right? The last two digits of what? Last two digits of n square would be same as the last two digits of 50 minus n whole square, which would be same as the last two digits of 50 plus n whole square, which would be same as the last two digits of 100 minus n whole square, which in turn will be same as 100 plus n square. The story can continue, but it doesn't really matter to us. I need to stop it somewhere, right? Technically here the stoppage is good enough for us from CAT perspective. The stoppage there is good enough, but can I continue the story? You can, but that doesn't really matter. So what matters to us is this particular bracket matters to us. Last two digits of n square is same as 50 minus n square. I am not proving n square is equal to 50 minus n square. Hello, all right, now there is very clear understanding. I'm saying that only the last two digits would remain constant. Last two digits of n square is the same as, equal to means is the same as last two digits of 50 minus n square, which in turn is the same as 50 plus n square, etc. Let me take a simple example. Let me say that, hey, let the value of n be 13. So I'm now trying to say that, hey, last two digits of 13 square. All right, last two digits of 13 square is what I'm talking about. 13 square is nothing but, okay, we know 169. I'm not commenting about this one. Last two digits are 69, which is same as 50 minus n square. What is 50 minus 50 minus n square means what? 50 minus 13 square, which in turn would become 37 square, right? 37 square is 1369. Okay, now I'm not interested in this 1 and 3. I'm not interested in this 1 and 3. I just want you to notice that, hey, 50 minus n square ends in 69. All of you know some speed calculation techniques, so you can also understand that, hey, this is 63 square. Therefore, you understand the last digit will remain 69, etc., etc. You may say that, hey, what about this here? 100 minus n, 100 minus 13. What is the value of n that we assume? 13. Therefore, 100 minus 13 is 87 square. Find out the last two digits of this number would remain 69. So other digits may vary. Other digits may vary, as I told there. This is an important property, very, very important property. So for example, let's say that, hey, how many numbers, how many perfect squares? If I just ask you that, how many last two digits of how many perfect squares are 44? Last two digits of how many perfect squares are 44? Very simple. All you got to understand is between 1 square and 25 square, how many perfect squares end in 44, right? How many perfect square numbers end in 44? You say that only one number. Hey, what is that, man? 12 square. What is that? Only 12 square. There is no other number which ends in 44. So you just have to know the squares from 1 square to 55, 25 square. You look at 1 square to 25 square, there is only one number which is a perfect square which ends in 44. Right? That is 12 square. And hence you say that, hey, other numbers are One number is 12 square. The other number is 50 minus 12 square. The next number is going to be 50 plus 12 square. The next number is going to be 100 minus 12 square. The next number is going to be 100 plus 12 square. You can write all that story, but not required. So only this story matters. In the sense, you are saying that the last two digits of 12 square, all which are the numbers which will end in 44. That is, tens and units place are 44. 12 square, it is true. 38 square, it would be true, right? 62 square, it would be true, and 88 square, it would be true. Now these are the four numbers, right, within 100 square which will have the last two digits as 44. That's a story. So multiple ways this concept helps. Now I'm not interested in talking about these stuff. This is not my area of interest for now, for today. Let's stick to the area of interest for today. Let's not digress from the discussion. Okay, coming back to this, how does this help me? Okay, you said this, but how this is going to help me out? For example, I just want to find out that, hey, because I just want to find out that you just want to find out that, hey, you got 83 square. Let's say that 83 square. I want to find out the last two digits of 83 square. It becomes it may become a little difficult. Okay, it is not really difficult. You want to find the last two digits of 83 square. I gave that, hey, last two digits of 83 square. You want to find this 83 square, just find out that, hey, is this fellow close to 0, close to 50, or close to 100? In your mind, quickly get that. It's a fractions of seconds decision, right? You look at this 83, don't look at 83 square, look at only base 83. Is 83 close to 0, close to 50, close to 100? Write the deviation. 100, it's close to 100. What is the deviation? 17. Therefore, you quickly say in your mind that last two digits of 83 square is same as 17 square. And I would know square still 25. Therefore, the last two digits of 17 square is 89, because it's 289, but doesn't matter, 89. And hence I quickly say that last two digits of 83 square is also 89. Let me tell another one. Let me take another one. Say I want to understand what are the last two digits of 67 square. Let's say I want to understand what are the last two digits of 67 square. One quick question I ask in my mind is this 67 close to 0, close to 50, or close to 100? You say that, man, this appears close to 50. Close to 50. What is the deviation? Positive deviation, negative deviation, doesn't matter. Simply take the deviation. What is the deviation? 17. Fair enough. Therefore, last two digits of 67 square is as good as the last two digits of 17 square. Again, it is nothing but 89. Okay, you got the point? You got the point? Now, shall we go to the model? We'll apply this in the model. You got the point? How to find the last two digits of any number? You just have to know the square till 25. Oh, that's thanks, Jack. Thank you. Good comment. Yeah, very encouraging. Thank you. Thank you for that comment. Yeah. All right. So there we go. Good. You got it. Yeah. Let's go. Okay. You got it. Let's go. Let's now try. So how do we, therefore, what does it mean to us? All right. What does this mean to us? Why did we learn that concept? Let's understand what does it mean to us. So here come. All right. Here we come with an example. 83 raised to power 124. The author wants to understand. Tell me the last two digits of 83 raised to power 124. Fair enough. So I'll quickly look at this 83 as the base. Follow me. All right, follow me here. 83 as the base. I'll ask a question to myself. Okay, you don't have to write in the exam putting these three lines, etc. Okay, that's an illustration because you got to understand what I'm thinking in my mind. All right, no. So therefore, I'm writing that. In your mind, you say that is this close to 0, close to 50, or close to 100? You say that, hey, it's close to 100. Okay, what is the deviation? 100 to 83. You say that, hey, it is 17. All right, therefore, already it is nothing but 17. In the sense, you are trying to say the last two digits of 83 raised to power 124. First step, hang on. 83 raised to power 124. First, you write this as 83 whole square raised to power 62. That's the first step. Okay, don't mistake here. First, make it as a perfect square. 83 square raised to power 62. This number can also be written like this. I took this number as it is. I took this 83 raised to power 124 can also be written as 83 whole square whole thing raised to the power 62. Now, I am now saying that, hey, 683 square, the last two digits of 83 square. Why? I'm not anyway interested in hundreds and thousands, does it? Last two digits of 83 square is as good as last two digits of 17 square raised to power 62. Why? I found out that the deviation is closer to 100. I got this 17 deviation from here, but not 83 raised to power 124 will be same. It is written 83 square, last two digits will be same as 17 square. It should be a square function inside. Okay, yeah, 17 square raised to power this. Now next step is what? Okay, let me find out the last two digits. Therefore 17 square, the the last two digits are nothing but 89 because it's 289. 2 doesn't matter to me. What matters is only 89. 89 raised to power 62. What did I do? Listen to this very carefully, right? Now, this is a phenomenon. So when I look at 3 or 7, all right, I said that it was a type 3 problem. It was a type 3 problem. The moment it came to 89, the number ending in 9, I made this as a type 2 problem. I am actually doing the backward integration. Simple. I'm putting in some steps there so that I'm doing a backward integration on this. So I looked at the problem. It was a type 3 problem. The number ending in 3 or 7, I said that it becomes a type 3 problem. Why? I learned one simple concept in between. The last two digits of some n square will be same as 50 minus n square, 50 plus n square, etc., just to convert it quickly into the type 2 problem. Okay, the moment you get into a type 2 problem, what do? You next step is convert this fellow to type 1 problem. Yeah, how do you do that? So you know that the unset divisor is 100. 89 divided by 100. Intentionally, you will write a negative number. Minus 11 raised to power 62. Intermediate step. How did I get this? 89 divided by 100. The negative remainder is minus 11. But author said that, man, I am not asking 89. I am asking 89 raised to power 62. Sure, I did this 11 raised to power 62. So therefore, it has become a type 1 problem. So not at this stage. What is this? This is same as 11 raised to power 62 has become a type 1 problem. My answer, 2 ones are 2 and this one as it is copied, therefore the last two digits are 21. Did you understand this? How we are actually looking at type 3 to type 1 to type 2 to type 1. Technically, we are trying to bring every problem to type 1. Did you realize this? Did you realize this? That's the approach basically, because type 1 is a mental problem, right? In the mind, you just get it in few seconds, right? I wonder if anybody wants more than 5 seconds for a type 1 problem. That's a reality. That's a reality. Not an exaggeration, it's a reality. Why do you need more than 5 seconds for a type 1 problem? So therefore, I bring every problem to a type 1 problem. That's the whole idea there. That's been the whole idea here. Okay, good. Right. That's why I classified. We classified, but then we bring everything back to the type 1. Very nice, guys. Everybody is understanding. Very good. Very good. Very good response. Okay, let's take a look on the other side. Why don't you guys try it now? Why don't you guys try it now? You might have got an idea about it. I'll give about a minute's time. Here is the question. Try this. Why don't you try this? It's worth. Take a minute and try this. And those who did remainders with me should not feel any awkwardness of doing these questions. Yeah, go ahead. Try this. Why, guys? Why it's taking time? Okay, do it with me. No worries. Do it with me. Do it with me. Yes, it's a bit challenging. Yeah, out of all the questions, yes, it is a bit challenging. No doubt. I agree with it. It is a little bit challenging. I intentionally, therefore, I gave a minute for you to think because it is challenging. Okay, firstly, the 2 doesn't matter. Let's understand that 100 plate doesn't matter. Let's not be overtly worried about the things which doesn't matter. Okay, 2 doesn't matter. And hence we are saying that 87 is what matters. Good. Some answers are flowing in. Very good. Let's keep it. 87 raised to power 127. Technically, I can write this as 87 raised to power 127. Okay. The moment I understand that the number is ending in 7, it becomes the type 3 model. But the point is, hey, you said that we have to write this as 87 square times of something. Man, this is an odd power. What do I do with it? If it is an odd power, why don't you pull out 187 outside and first write this as 87 into 87 raised to power 126? Do this. If it is an odd power, unlike the earlier power was even, here when you are doing this 83 raised to power 124, it was an even power. So it was okay. All right, yeah, it was okay. But the point is what you are trying to say. It is an odd power now. If it is an odd power, why don't you pull out 187? Pull out one power there and rest of them you make it as a package, right? Rest of them you can package. So package this. Therefore, you say that, hey, this is 87 whole square. So then you say that, hey, this is nothing but 63. Good enough. All it making sense. 87 raised to power 1. Bring this number as it is down. Okay, this number, we already know that 87 is, you ask a question, is this 87 close to 0, close to 50, close to 100? Okay, all this happens in your mind within no time. I'm just telling you that how you make that decision. 0, 50, 100, you understand that, hey, this is close to 100. How close to 100? 13 close to 100. Therefore, you say that, hey, this is as good as 13 square raised to power 63. That what pops up in your mind. Okay, what are the last two digits of 13 square? Therefore, 69. 69 raised to power 63. And you have this 87 coming up. Okay, good. So now this has become a type 2 problem. At this stage, this is a type 2 problem. One step you converted this to a type 2 problem. 69. So you take 160. I'm doing it offside here. 69 divided by 100. The remainder is minus 31. Okay, but raised to power 63 minus 31 raised to power 63. This is what I kind of have there. I'll let minus 31 raised to power 63 is nothing but minus of 31 raised to power 63. I should be writing this. All right. So I'll find the last two digits of this. Therefore, 3 into 3, 9. Therefore, you say that, okay, this number is nothing but minus 91. Minus 91 means what? Am I doing it right here? I think everything is fine here. I guess I'm not doing any mistake, right? Okay, minus 91. So you are writing this as minus 91. Minus 91 is nothing but 0, 9. I can write it as 0, 9. I say that, hey, from here, the remainder looks like 0, 9. Guys, are you all with me so far? Are you all with me so far? Is this making sense? Everybody clear on this? Clear about this? So far, is this clear? Understood? Clearly understood so far? We got this 0, 9. The 0, 9 part is clear, right? Yeah, no, multiply this manually. That's it. No, what big deal? I'll multiply this manually 9 7 times 63, 9 8 7 72, 72 plus or 72 plus 6, all right, which becomes 78. Therefore, the last two digits are nothing but 83, which becomes your answer. Yeah, no worries, no worries. You got the answer? Everybody got the answer? Yes, this was a little tedious. Of course, little tedious. Therefore, I wanted you to think for about a minute. How do you handle this? Right, because now I don't want you to assume that, okay, things are going to be so easy kind of. Yeah, sometimes they make it tedious. You got to do these kind of adjustments where you say that, okay, man, I will plot 181, then I will get some odd power, or odd power with a negative number. So all these things will come up, but then it's almost the same out there. All right, yeah, that's the answer. Got till this means what? Find the last two digits. No, 87 into 9. Why don't you multiply, Mohit? What big deal, man? It's a 3-digit number. Get the last two digits as the answer. Yeah, 87 into 9. Oh, you added, you are trying to say, okay, no problem. No problem. Yeah. Okay. No worries. No worries. That happens. No worries. Okay. So that concludes our type 3. That concludes our type 3. Let's go to the next type. This is very simple one. All right. Yeah. No problem, no problem. That's okay. Make mistakes in the class. Make mistakes in the class, no problem. Don't make mistakes in the exam. That's all I keep telling people. Make mistakes because I don't want people making mistake in the exam. You get everything right in the class and making mistake. No, make mistakes, learn from your mistakes, and then don't repeat those mistakes. Make new mistakes in the exam. All right, in the new kind of questions, you want to make a new mistake. That's fine. I also make some new mistakes in the exam. There is nothing wrong about it. But don't make the same old mistakes. Learn from them. So and ensure that, okay, we don't make the mistakes which we already did. It's okay to make mistakes in the classroom. While you are learning, it's okay to make mistakes. Yeah. But refrain from silly mistakes. I don't like that word. People saying that silly mistakes, etc. Mistakes do happen in a hurry. But yeah, let's not brand it silly mistakes and blush it off, which is not the right way to understand it. Okay, let's come back to this. Now see, the number ending in 5. Number ending in 5. Again, the proofs exist just like I gave in the beginning, but the way I classified it. Likewise, the proofs exist for it. The all proofs can come from the binomial. Very simple. So therefore, in the beginning of the lecture, I did one binomial. Split it like that and work through the binomials, you will get the answers. All right, that is the whole stuff there. That's the whole stuff. But let me put it to the perspective again. What matters to me? All right, what matters to me? The moment you see 5, there are only two answers possible. The moment you see the unit digit as 5, irrespective of what is in the tens place, what is the year in the place, irrespective of this, only two answers possible. Either my answer should be 25 or my answer should be 75. I just have to make a decision between the two. That's it. The proof comes from binomial. The very first question I solved on binomial. After that, I didn't solve. Therefore, the proof comes from there. Okay, only two answers are possible. 365 raised to power anything. All right, now, so you have a number ending in 5. There is a here, there is a B here, whatever you want to write, you write all it before that, above that, below that, all of it. So only two answers are possible. My answer should be 25 or my answer should be 75. How do I decide that? Right, so proof is from binomial. I'm not going to prove it, not required. I already did in the beginning of the class. How do I going to do this? Only two numbers matter. Look at this place. Look at the tens place of the base. Listen to this carefully. Look at the tens place of the base and look at the units place of the power. You may say that earlier also we did the same thing, sir. I'm saying stick to the same thing. You don't have to stick to any other different thing, because when I said that, hey, when we looked at the first example, whatever it was, 61 raised to power 123, something like this. So what did we do? I said that, hey, this is a no-brainer. This is going to be 5 here, or this is going to be 1 here. All right, this is no-brainer. I said that focus on this, focus on these two. Now also I'm telling the very same thing. Now also I'm saying that focus on the units place of the power and the tens place of the base. What about the hundreds place, etc.? Doesn't matter. If both are odd, what do you mean by both are odd? All right, now both are odd. What do you mean by both are odd? Both are odd means if this odd and also this becomes odd. Now you have two sample spaces. There are two sample spaces. What is one odd I'm talking about? I'm talking about the tens place of the base. Let me write it as TB, tens place of the base, and the units place of the power, exponent, unit place of the power. If both of them are odd, only then the result is 75, otherwise 25, otherwise 25. Only if both of them are odd, the result is 75. Which both are odd? The tens place of the base, or that's this arrow, tens place of the base, and the units place of the power, units place of the power. If you find both of them to be odd digits, then the result is 75, otherwise 25. Okay, what do you mean by otherwise? One can be odd, the other can be even. Or you may say that no, yeah, tens place of the base is even, but the other one is odd. No, both of them are even. All these cases, it becomes 25. Therefore, easy to remember. Just remember this. If both are odd, write it as 75. Otherwise, write it as 25. Let me take a look at this particular question here. I'm looking here. I'm looking here. Hey, I have one even number here. Therefore, the answer to this question is 25. Simple. Okay. Let me look at the other side of the issue. So anyway, this is 5. Therefore, there is no problem. I just have to decide between is my answer 25 or is my answer 75. I look at this. Hey, what is this here? Odd. I look at this. What is this here? All right, this is also odd. 3 is odd. The unit digit of the power, that is odd. Since this is odd and this is odd, my answer is going to be 75. Understood? Understood. Everybody understood this? Only two decisions. That's it. That is it. All right. This is all you got to do when the number ends in 5. When the number ends in 5, this is all you got to do there. Got it? Quick guys, quickly respond. Simple one. Proof is through binomial. I can prove it and show it to you, but doesn't matter. I already showed it in the beginning. Now you should be having the capacity to do it to yourself already if you are interested in proof. Not interested, remember what I am saying. Remember and proceed. Okay. All right. Others other than Rishabh, Keval, Mohit, why? Others are not active. Why don't you guys get active? Right. I always say that like sit with your laptop or your desktop. Or Rishabh says that he is comfortable on his mobile also. Yeah, whatever it is, be comfortable so that you can respond also, right? You can respond also. That's always the good way to learn, because it's as much as you need, I have the confidence in you. So you have to send reciprocate saying that, okay, we are understanding, right? That is when I develop confidence in the student. So if you are very tacit from the other side, it's not great to teach. Okay, good. All right. So one last model left. What is that model left? The one last model when we started the beginning of the lecture. So we classified that particular data. The structurally we classified it. All right. This is covered, odd, odd, covered. Only thing that is left is even, which is left there. So this requires maybe about another 10-15 minutes. So I can take this time now, but then I will do it tomorrow along with the units digit. I will title the lecture as to find the unit digit of an exponential number. But yes, I know that, okay, another part is left. We will cover this as well as this. We will cover this tomorrow, right? We'll cover this tomorrow. 4 out of 5 models we covered. Only the fifth model is left. So that may require about 10-15 minutes, all right? Because there are certain variations to be understood there. I may require about 15 minutes. We will pull the time off tomorrow and we will learn that particular one model tomorrow. Tomorrow I'll be doing only one lecture. Tomorrow I'll be doing only one lecture, that's at 10 p.m. How to find the unit digit of an exponential number. We will look at that particular model. And along with this, we will also look at this. Therefore, it may also become a short lecture. And if I can add something to that agenda, let me also add something to that particular agenda. So this is the only lecture for tomorrow, that is Saturday. So just note that down. So there will not be an afternoon lecture tomorrow. There will be only a late evening lecture tomorrow. So if you like the way we are discussing it, always press the like button before you do. Don't like it, don't bother, right? If you like it, put the like button before you do, before you leave, and then you can share this link with others as well. Let them also watch it, get benefited, right? So that's pretty much about today. Yes, there are some of the educators who have launched the plus courses in the recent past, and of course there are few batches which are going to be launched tomorrow. So they're primarily one for cat 22 and one for cat 21. If you want to understand them, what you got to do is they would have made a 1 or 2 minutes of short video as to what exactly they want to cover in this particular course, how this benefits a student in this particular course, right? So you can take a look at that, and then based on that you can attend their lectures, etc., right? Okay, I will update my plus course by tomorrow evening when I take the 10 p.m. class. I will tell you like what I am trying to do on the plus course in this particular month and the subsequent months. I will start with one of the courses in the next week. I will update you about that. Yeah, that brings to the closure of this particular lecture. I hope everybody learned. I think everybody learned something today's lecture. So I will hope to see you guys. I will see you guys maybe. Yeah, that's another important thing. So on Sunday, block this particular time, 19th September, because there are 500 people who are going to get the scholarships, and very likely that people can get this particular scholarship. Therefore, simply write it. It's a 1 hour test. You are lucky if you get the scholarship. It's good. If you get 100% scholarship, nothing like it. Nothing like it. Yeah, great. All right, that brings to the closure of the lecture. So any comments here, anything that you guys want to ask it, put it there. Otherwise, I will see you guys tomorrow night at about 10ish. Yeah. So those who are dropping off from the meeting, good night to you guys. Sleep well, eat well, rest well. I'll see you tomorrow night, and keep studying, and God will add a lot of blessings to your hard work. Yeah. So any comments, you can put that comment. I will wait for a minute or so. Something to be asked, you can ask now. Yeah, good night, Preet. Where were you through the lecture? Now you are saying good night. Anyway, thank you for that. Sure, Nazia, good night. Good night to all of you. Good night. Good night. Good night, guys. Catch you tomorrow night then. So there seems to be no comments. If there are any comments that you get, you can put that offline as well. I'm signing off for now. See you guys tomorrow night at 10. Bye till then.